Hi guys, here's the video that goes over day 2 inverse functions of our functions unit. After this video you should be able to find the inverse of a function and determine if two functions are actually inverses of each other. So an inverse function is basically another function that will undo the operations of the first function. To be able to find the inverse, you're just following these 4 steps that I have in the box over here. So your first step is to change f of x to y. So instead of writing it as f of x equals, I'm going to write it as y equals negative 1/2 x plus 1. So first step, done. The second step is to switch the x and the y. So I'm just going to switch these variables. So instead of y equals, I'm going to have x equals negative 1/2 y plus 1. Second step, done. The third step is when you're actually doing all of the work. So the third step is to solve the equation for y. So I'm trying to get my y by itself. Well, what is happening to the y? You're multiplying by negative 1/2 and adding 1, so I need to undo all of that. So I'm going to start by subtracting 1 from both sides. So I have x minus 1 equals negative 1/2 times y. Again, trying to get that y by itself. Since it's being multiplied by negative 1/2, we want to divide by negative 1/2. But since we're dividing fractions, what you really do is you multiply by the reciprocal. So I'm going to multiply both sides by negative 2. When I do that, negative 1/2 times negative 2 gives me positive 1, which gets your y by itself. I'm going to go ahead and continue over here. So now I have y equals negative 2 times x minus 1. If you want to distribute the negative 2 into the parentheses, you can. You don't necessarily have to, since we're trying to solve the equation for y, and you have y by itself, you're pretty much done. So step 3 is done. Step 4 is just to change it back into function notation. So you're not going to use f of x. Instead, we're going to use f inverse of x, since f of x is already taken by the original function. So I have f inverse of x equals negative 2 times x minus 1. And that is the inverse of f of x. Alright, let's do another one. For this one, again, step 1, change f of x to y, or in this case it's h of x. So I have y equals 4 times x plus 1 cubed minus 1. So step 1, done. Step 2, switch the x and the y. So I have x equals 4 times y plus 1 cubed minus 1. Step 2, done. Step 3 is to solve the equation for y. So there's a lot going on with this y. I'm adding 1, I am cubing, multiplying by 3, and then subtracting 1, so we need to undo each one of those. So I'm going to start by adding 1 to both sides. That leaves me with x plus 1 equals 4 times y plus 1 cubed. I'm going to divide both sides by 4. That leaves me with x plus 1 over 4 equals y plus 1 cubed. I need to undo the cube. The way that you undo a cube is by taking the cube root. So I'm going to take the cube root of both sides. That way my cube and my cube root cancel. I'm going to continue over here because I'm running out of space. So now I have the cube root of x plus 1 over 4 equals y plus 1. Still need to get that y by itself, so I'm going to go ahead and subtract 1 from both sides. So now I have y equals the cube root of x plus 1 over 4 minus 1 on the outside. And then your last step is to change it back to function notation. So I'm going to go ahead and erase this y, and instead of y I'm going to write it as h inverse, since this was the h function. And we have the inverse. For letter E, it's the same thing. I'm going to go ahead and combine steps 1 and 2. So I'm going to change my g of x to a y, and then switch the x and the y. So I now have x equals the square root of 5y minus 15, and then solve for y. So I'm going to square both sides. That leaves me with x squared equals 5y minus 15. Add 15 to both sides. And divide both sides by 5. So now I have g inverse of x equals x squared plus 15 all over 5. Step 3 done. Step 4 done. Do not worry about letter F. We did not do it in class, so you can go ahead and skip problems like that on your homework assignment. For G and H, finding the inverse using exponential functions and logarithms, I'm going to go ahead and do the same process. So I'm going to change my f of x to a y and switch my x and my y. So now that leaves me with x equals 5 to the y. Now the fastest way to get the inverse for this, because again we're trying to solve for y, the fastest way to do that is to change to log form. If you recall from the last unit, exponential functions and logarithmic functions are inverses of each other. So if I change this to log form, I have a log base 5 of x equals y. Because a logarithm is an exponent, so it has to equal the exponent. And our goal is to solve for y, which we did. And then just rewrite it in function notation. So this is f inverse of x equals log base 5 of x. And then for letter G, if I switch my x and my y, I have x equals log base 2 of y. This is like the scenario where we had log equals a number and you change it to exponential form. So I have 2 to the x equals y. Change it back to function notation, so I have g inverse equals 2 to the x. So the logarithmic and exponential functions, when you're finding the inverses of each other, is actually very simple. If you'll notice, our exponential function right here was 5 to the x, so your base was a 5. So that means its inverse is going to be a log base 5. For letter H, our log was a base 2. So that means the inverse is going to be an exponential function with the base 2. So there's really not a whole lot of work involved for those. So now moving on to the second example. The second example is when I am asking you to verify if two functions are actually inverses of each other. So the first example is finding the inverse. The second example is verifying that these two functions are inverses. The way that you do that is by taking the composition. The composition is what you did in day 1. So the composition, you're taking one function and plugging it into another function. So you can do either f of g of x, like this one says, or you can do g of f of x. It does not matter. I usually stick with f of g of x. So that's what I'm going to do for these problems. So f of g of x, using what we know about the composition, means you start with g of x. So I'm starting with g of x, and I'm going to take that and plug it into my f function. So now I have 3/4, but instead of x, I'm putting in my g of x because that's what the composition does. The composition takes one function and puts it into the other one. So here was g of x, here is g of x being plugged into that x into your f function. From there we're just simplifying, so I can distribute the 3/4 into the parenthesis. 3/4 times 4/3 is 1, so that leaves me with x. 3/4 times 8 is 6, minus 6, keep simplifying, gives you x. Now what you're looking for is if two functions are inverses of each other, that means when you take the composition, it equals x, which this does. So yes, these two functions are inverses of each other. Let's do another one. So for this one, I have f of x equals 2x squared plus 1 for x is greater than or equal to 1, and g of x equals the square root of x minus 1 over 2. Now, this piece of information is just kind of extra information. You don't necessarily need it. We would need it if we were graphing, but we don't really need it for this. But again, I'm going to go ahead and do the composition. So f of g of x, I'm going to start with my g of x first. So I'm taking my g of x, and I'm putting it into my x into your f function. So I have 2 times the square root of x minus 1 over 2, quantity squared, plus 1. So if you see, I have my g of x going into x for the f function. And then from there we simplify. So the square and the square root cancel, because those are inverse operations. So I have 2 times x minus 1 over 2 plus 1. My x is being subtracted by 1 and divided by 2, and you're also multiplying by 2. So these 2's will cancel. So that leaves you with x minus 1 plus 1, which is x. So yes, these are inverses of each other. Because again, our goal is when you take the composition, it should equal x, and if it equals x, they are inverses of each other. Has to equal x, can't be negative x, can't be 2x, has to equal x for them to be inverses. Alright, I hope that video helped you figure out the material.